Okay. All right. Right. So I think this is towards the end of the third unit. You're all learning the last two, trying to understand the last two illustrative programs. So basically, searching is in computer science, right? So it's all about searching. Searching is one of the most important concepts in computer science, and obviously we use computers and programs to search for things. The search is important because there are always something that you're searching for, and the searching algorithm helps you find that element that you're looking for. Many different types of searching algorithms, so which you already have mentioned now. There are only two that you know, I think, right? Linear search and the binary search. Are there only two types of searches?
I think so, sir.
Okay. Do you know that your search you perform some kind of search in your own lives every day? An example of what search you do, for example, on your mobile phone. Do you know if you're doing any search? What is
Yes,
the most common search that you do on your mobile phone?
In Google.
Google. Okay. Something more often than that. Maybe you are. Yes, you're right. Okay, then I'll ask this question this way. Then, what is the second most search that you do on your mobile phone?
A contact.
Sorry?
A contact.
Account?
A contact number.
A contact. Okay, yes, very good, Samuel. Yes, you are searching for. So imagine that I'm doing a search on my phone. This is typically how it will happen. So I'm searching for professor's number. Satish, I write, I get 5-6 entries. Then I do BABU, then that reduces to 3. Then ultimately I find the one that I want. And then from there, I should be able to launch and call, right? This is typically what happens. So this is a search. So you are using search on your own phone, right? So what type of search is this? Somebody other than Samuel, please don't be shy. Only by saying something and being right or wrong, you'll remember it better. Otherwise, only Samuel gets the maximum out of this session. And everybody is silent, then Samuel will speak up. Come on. How about Sanjeevi? You want to say something to answer my question? What type of search is it? There's only two that you know, right? You want to pick between the two, or you think there's something else?
Sanjay.
Varnisha, are they all attending the class or just logging in and doing something else?
No, sir.
So, okay, Varnisha.
Yes, sir.
Yes, tell me, don't be shy. You can be right or wrong. Nobody's going to give you anything better or less.
Sir, one more time you ask question, sir.
Sir, it
You
is a
saw
new.
the search that I did, right?
What?
Did
What,
you see
sir?
that or you didn't pay attention to it?
Sir, what, sir? Your voice are not audible, sir.
What? Really?
Sir, I think there's a little bit echoing. That's why.
Echo.
Yes,
There's
sir.
no echo here. I'm not logged in anywhere. How can there be an echo? Is there an echo, Professor? It
Now
was
it's okay,
there
sir.
before. Now
Now it's not echoing, sir. Now it's not
there is no echo now. All right. I don't think Varnisha is paying attention. Anika, do you understand the question I
Yes, sir.
asked?
Yes, sir.
So between the two, you want to select one type of search, or you think there's some other type of search?
Actually, it's a direct type of searching. You could not include either in linear search or binary search.
Very good. Nice. That's an intelligent answer. You're right. So this is called tree search, tree data search. I mean, I don't know whether whether your syllabus even talks about tree data structure. Professor, does it do it before they graduate? I mean, this is CSBS as well.
Yeah, sir. Data structure next semester. Data structure using Python. Next semester they have a syllabus.
Maybe you will get introduced to this new data structure, but basically this is what happens when you use a tree. It's not a link. It's not a list data structure. It's not a dictionary. I guess it is some kind of a more elaborate dictionary type of a data structure. But basically that's what happens when you type TAI. When you type, suppose you want to type 10, you are searching for 10, right? So T, then E and N, right? And then T, when you type T and E, it shows you 3 options: T, TED, or 10. So this is the kind of thing that search happens. So the intelligent answer to how many type of searches, yes, as far as the syllabus goes, you are asked to know about linear search and binary search, but there's more than 2, right? And especially the one that you use to, yes?
Yes.
The thing that you use to look up for a phone, when you want to make a phone to a particular person, that is neither linear search or binary search, but it's something, it has some element of a binary search, but yeah. Now, before we go into before I go and give a technical presentation on what binary search is, I think binary search is something that you have your brain already knows, is my persuasion here, right? So let's put your brain to test whether it knows binary search. Now let's search for 50 in the list of numbers I'm giving you. Okay, let me see who's the first one to answer this. The question is 50 there in this list? Isn't that what it is, right? Binary search is that you give a number and you want to know whether that number exists in that list, right? And then therefore this is an illustrative program because you've already learned the list data structure, and something like list is important if you want to assemble things and search among those things. Is 50 there or not?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Right. So describe the algorithm that you ran in your head. Is it a linear search that you did or something else?
Not linear search, it's something else.
Yes. Now let's again put your brain to work here, right? Search for 100 in the list of numbers I give, right?
Okay, sir, got it.
Yes, sir.
Yes. So
Yes, sir.
you're in a sense watching your own brain work, right? So you're running it imagine you're running a debugger and you're watching your own brain work, and pay attention to what algorithm you're running. It's a linear search or something else?
No, sir, it's most likely to be a binary search, I guess.
Yes.
Yes, let's test it again. Search for this number 160 in this number of list of numbers given.
Yes, no, 160 is not here.
No,
Yes,
sir.
160.
There is no 160.
No, sir.
Right. So basically, if you had to write down what is going on in your head, and if you were to put it down in English, what was going in your head, that would be the pseudocode for binary search, as a matter of fact, right? And this is a little bit of a comparison of what you do with linear search compared to binary search. Linear search obviously takes longer to find the number 9 in this particular list. But imagine this, watch again what happens on binary search in the top, right? At the start itself, it gets to the middle, right? That's what you did in your own head, right? That's
Yes,
what
sir.
you did. When you look for 320, you're looking for 160, and you are somewhere, you didn't start from 1, 2, 3, 4, 5, 6. Definitely.
No,
So your brain is already knows that given this is the problem, you have to move to a binary search mechanism, right? So that's exactly the simplified version is what I'm showing you here. How it keeps moving to the right is something that we'll elaborate more. A little bit of a more complicated example where you're trying to look for 37, and then the deeper mechanics of how the binary search happens. So it's always good to see, I'm beginning with the end in mind, right? So binary search, this is the kind of binary search we want to write. We want to be able to produce in code compared to the sequential search. And then you understand there are some markers and stuff that we are going to use, which we come to later. But before I get there, there are prerequisites, right? So if you don't know slicing, you're going to find this code, this whatever code I'm going to present difficult. I'm assuming you all know slicing well. And if you want to refresh your slicing fundamentals, you can go to that memcode link and then look it up. And your index-based fundamentals are also very important. You must know what index values mean, what are valid, what is invalid indexes, how do you access an element in a particular index. Of course, the good old while loop you must know, and of course, if else. So all these things you've already learned. This is the thing that we're going to be building upon, right? For this session, Professor Satish wanted me to introduce you to a more of a test-driven methodology of how to understand and come up with the code for binary search, right? Even if you know the binary search, ignore that you imagine that you don't know it. I'm going to imagine that I don't know it and start and build the code from base, right? This is typically how professionals learn. When a professional Java programmer wants to learn JavaScript, for example, or wants to learn Python, for example. He or she approaches the language in this manner, and CyberDojo is a useful tool to accomplish. So this is the code that we're going to try and accomplish, but I'm going to start from scratch in terms of showing you how to do that. All right. So basically we start with this. This is CyberDojo. CyberDojo gives you the option to define test cases. So it's actually tests, right? I'm going to write a very simple test, and then based on the test, then we write up the code, right? So basically, before we even write up any logic for binary search, we first have written a sample test, which is basically telling us what is it that we want to, what the program to do. And kind of, this is equivalent to what I asked you to do, right? I asked you to look for 50 in a list of 100. Here I'm simplifying it to, can you look for 5? Is 5 available in the list? Is 5 available in the list? It's a question.
Yes, sir.
Yes, sir.
Yeah.
Sir.
So what should be expected? What if you search for token in this A list? What should we expect? We expect the Boolean value true, right? So what are we trying to do here? We're trying to write a program that does binary search on a list of numbers. If the number is present,
Return true.
if it is absent, return false, right? So that is basically what it is. So that we translate into a test case, right? This is how we translate into a test case. Given a sample list, which is, by the way, has to be sorted, which is a sorted list. We look for token and expected the function. If you write a function called binary search, it must return expected. Everybody understand the test case?
Yes, sir.
Yes, sir.
And so what is it that I write in binary search? I've defined this name of the function. I've given it two parameters that it has to accept. And for now, I don't know what the logic is. And so I'm just returning something completely meaningless, because it's supposed to return true or false. But right now, I'm just returning something called -1. So when I do this, I get a response back. The output is this. It says, look, I expected it to be true, but you're returning -1, right? So this is how we run. We start with a failing test case. This is a failing test case, right? So tell me how to make it pass. Hello? How do I make this test case pass? What is the simplest code you can write to make it pass? Hey, it's not a IIT JEE question. Very simple question. Don't be afraid to be wrong. Go ahead. Monish?
Sir.
Silence is not accepted.
Sir, instead of return 91.
Return?
Instead of return 81, return true.
Very nice. Very good, Manish. Good. So immediately when you have a passing test case, you're light turns into red. So this is called red green. Red green. That's what the thing is. The idea is to run when you write a failing test case and you make it pass, then you're doing TDD. Right. So now we return true. Obviously, that is true. But then, how do we know it is true? Because we know that we found 5. Mentally, you found that 5 is already there. Where are you searching for 5? We are searching for the midpoint, right? How do you find the midpoint of a list? How do you find the mid index of a list? How do you find the index, the middle value of a list?
Length of a list divide by
floor division of 2.
Divide by 2, or is it divide by double divide, or what do you call that? Double
Double
divide?
divide.
double divide.
Double divide, sir.
Is there a name for that, Professor? Or what do you call that?
Floor division.
Floor division. Very nice. Very good. Who said that?
Kalai service.
Kalai Chelvi. Good. Thank you, Kalai Chelvi. You made me learn something. Double floor operator, right? It's called is that the floor operator you said? Floor division operator. Okay. So we get the floor division operator. If you don't use the floor division operator, you get a float. Then the float cannot be a valid index, and therefore it will fail. So how do you get the mid value? Mid value is, somebody tell me, how do you find mid value?
A list of mid, sir.
Very nice. Good. So let's print these things just to make sure what is it that we're getting meaningfully. If you want to print this, I want to put a new line. Mid, I say mid, tell me this is mid, and tell me what is mid value. Obviously, because you're learning doing this, we just want to understand what it is before. So we continue to keep return true as our logic. We just wrote additional logic. We're not using it in our code, but we're just getting values out, right? So we got mid value 2. Mid index is 2, and so at the index our A list of 2 is 5. So 5, it says 5 is good, right? So instead of returning true, so what we really are saying is, we are in your head, what you're ascertaining is, you're saying if token, which is 5, is equal to the mid value, then you're saying return true, right?
Yes,
if
sir.
it is not equal, then you're actually not returning true, but you must be returning false.
False.
So with that, I have improved the logic. If you look at the logic, what did I do? Instead of just simply having return true, we used some logic ahead of the time, and then this code we actually replaced with a conditional. Make sense?
Yes.
Okay. Now let's go on to write another test. So let's define test. Somebody tell me what you want to do. What is the next test you can do? Can we find something else?
Yes, I have a doubt.
Yes, you have a doubt, Samuel. Yes.
So if we got like multiple numbers, like if the list consists of 1, 2, 2, 3, 2, 5, and we will like to find the index value of the element 2 when.
Well, we'll get to that, right? That is the next version, right? Next complicated version, Samuel. Right now we're just saying, is it there or not? Correct? That's our goal. In terms of finding, you want to find the index and return it, we'll do that the next version. Okay. Right now, tell me another test case, simpler test case. Maintain the same list. We still want to maintain the same simple list, right? Tell me some other test that you will. Tell me a test that will fail this logic. That's the best way to say it.
Find if an element 10 is present in it.
Before 10, let's look for 3, right?
Yeah, okay, sure.
Find 3 in, this should be test. I don't know why I keep writing test. Mentally, I'm something wrong there. List, okay. In the sample list, right? So this is a strange way. Normally, you are not expected to write test cases, name functions like this, but this is the convention. The test case in a sort of self-document itself, right? What is this test trying to do? It's trying to find 3 in the sample list, right? And so token is 3. and we expected should be what? True or false?
True.
True. And therefore we copy this and then bring that here as well, save some typing. So this is 1. So will this test pass or fail for the logic that we have?
Yes.
Can you predict? Who's going to predict? Predict red, amber or green? Amber is if you get syntax errors. I don't think we're writing any syntax errors. Are we predicting red or green?
Go for greens.
Go for green. Okay, auto revert if wrong. Auto revert if wrong. I've never used this, by the way. So predict, how do I predict this? Press green. It's failing. So why is it failing? Oh, okay. I won't go there. So anyway, I myself haven't learned that feature, but it's interesting to know that that feature is there. So what do we have here? We have wrote. We didn't write. What happened to our? What? I'm getting confused. What's happening here? Okay, what? I'm surprised. I'm sorry about this. Okay, so we are wrote a test. Where's our test go? So let's go grab that, save some typing. So then what are we doing? We are bringing this here again. We're going to write this test case. So as somebody predicted, it's going to pass. It didn't pass, so it's going to fail, right? So that's what it fails now, and it fails and tells us that look, it expected to be true, but you send back false, and that is because it only checked in one location, and our logic is returning like this. So if we have to do this, we just have to again. We know that we have to look for if token is equal to mid value, then it's then. If token is less than mid value, which is what our situation is, right? Then you want to throw away the top part of the list, correct? How do you throw away the top part of the list? You say A list is equal to mid. Slice only until the mid, right? And having sliced the A list, now again we repeat the same situation here. We find the mid value, we find mid value 1, we'll print it, and again we are asking the question, is the token the same? So once we do that, then the test case passes, and you can see from the prints, first it looked for in the mid value, it tried to find whether 3 is there in the index 2, or then it tries to find whether it's in index 1, which is there, right? Mid value 135 is right there. You look at 3 is at 1. So once it found it, then it returned true. Now, this is the logic that it writes up. Now we look at this logic and say, look, let's remove some duplicates, right? How do you remove the duplicate values? We say while a list, while there is something in the list, you got to do all these things, right? Then we are saying we are moving all this into the while list. And while in the while list, we are saying, is there some duplicates we can remove? This is almost the same as this. So we can remove this. So we just didn't change any logic. We just introduced a while loop. By introducing the while loop, you made some of all these red ones. Red are the code that we had before. We removed all the reds because they're all duplicates and introduced the while loop. So by introducing the while loop, we make the code simpler. The logic remains the same. And now both our test cases pass, right? Somebody else, give me another test case. test find 1 in the sample. Will this logic work? Will this test case pass or will not pass?
It should.
It should pass.
Yes, it should pass. Very good guess. Yes, so it passes. Now let's go and write another. Give me another test case. Somebody else? Somebody, please, come on, quick. We're losing time.
So 7.
Nice, good guess. Tell me how do you want to define this test case? Test
Find
7.
7 in the sample test.
Yes. Tell me the logic. Write me the test case as well.
Writing a list.
Copy. We'll place that. And what is the token value?
7.
7.
7. So will this pass or fail?
If it will fail.
Good. Is it Samuel guessing?
Yes.
Others can also guess. It's okay. You can guess along with Samuel. Come on. The idea is to be interactive. If you are interactive, you get better out of the session. And so it's timing out in some weird case. And that is because why? Because we've handled the if situation. We've not handled the situation when the token is higher than the.
Yeah, it's only lower and equal to, therefore.
Yes. So how do we done? In that case, we have to throw away the lower part of the list, right? How do we throw the lower part of the list? What is the logic? Somebody other than Samuel, please tell me the logic. Code, please.
A list equal to A list of mid colon, sir.
Mid colon 1, right? Is it mid colon 1? Okay, let's try with that. I've never tried with that logic, but you might be still right. So let's do this. It does pass. Very nice. Good job. Is it Shweta? Nice.
Yes, thank you, sir.
So it could be mid. Now mid, what is there in mid? Mid is anyway not, it is already found that mid does not match the token, right? So you might as well become a little bit efficient and say it's mid plus 1, correct? Also should work, correct? You agree, Shweta, right? You only said mid colon. Why not go mid plus 1? Because anyway, mid is not, mid values, the token is not there at mid either, right?
Okay, sir.
All right. So good. We got 7. Do you think if I change it to 9, it will work? Find 7 or 9. Will 9 also be found?
Yes, sir.
Yes, sir.
Okay, let's do the test. Yes, it finds it. Okay, give me one final test. There's one more test that has to be done to make sure your code is correct. Somebody.
5.
You want 5? Did you say 5? 5 we've already tested, right? That was our first test.
Sorry, sir.
Out of the list, if any element from out of the list.
Yes, give me an example.
10 or 2.
So how do you name this? It's not in the list. A list again, we are going from 1, 3, 5, 7, 9.
Token has 2.
Token, you want to look for 2. Nice. Good test. What do you expect?
False.
False, exactly. So then we are doing this. And will it pass or fail?
It should pass.
Good. So that's the logic. And that's the same thing that we have here. I brought it over here. That's the logic. So this version of binary search, where we're just expecting you to return whether true or false, whether the token that you're searching for is there, is the simplest way of how to understand binary search. Everybody understood?
Yes, sir.
Yes, sir.
Yes, sir.
Now, the more complicated one is the index-based search, which will be get to very quickly and shortly, right? How are we doing on time? Let's take a break. Professor, ask them to take a break. What is your usual practice? You're mute, Satish.
No, sir. No, sir. I'm not mute. Actually, it button was not working. Okay, all of you turn around the room 3 times. Okay.
Wherever you are, stand up and turn around in your same place 3 times.
Yes, sir.
Pray to your favorite God and turn around 3 times. Good. All right, let's do a quiz, which will reinforce. Everybody participate together. Let's see if you can all score 10, right? So, Professor, you pick the name. I'll ask the question. What does a searching algorithm? What does a searching algorithm do? That's the first question.
Kalai. Yeah. Tell me the answer. First question.
It's okay if you're wrong. Go ahead, Kalachelvi. We don't want to waste too much time. Come on.
So search through a set of data.
Does everybody agree? Yes, that seems right. Search through a set of. Okay, what would be needed if searching algorithms didn't exist?
Ganeshwari.
Sir.
Yeah.
You don't pick Panama.
No
Even if you're
issues,
right
Ma.
or wrong, doesn't matter. It's
It
okay.
is not a matter.
Others can
Option
correct you
3,
if you're.
sir. A
Huh?
new set of. Option 3, sir.
Anybody disagree? Agree?
Any others?
Option 2, sir.
Yes, very good. Next.
Suji, option
Which
two.
of these is a type of searching algorithm?
Guru Prasad. Okay. Jaban.
Yes, sir.
Yeah.
Edon Solupa.
What?
Hey, it can't take so long. The
Second
other
option,
class. Huh?
Second option he tell that actually.
Second option. Are you
Yeah.
sure? Word search எங்கேயுமே நான் பழகலையே. నేను புது search சொல்லி கொடுக்குறேன் எல்லாத்துக்கும். Serial search இருக்கு, binary search இருக்கு.
Okay. Yeah, try to participate each and everyone, not only for my
Serial search.
Serial search.
Yes.
Sir, serial search.
Serial
What does a
search.
serial search do?
Look at the first item of data.
Until it finds the data item requested. Yes, very good. What is an advantage of a serial search?
Simple algorithm.
Simple algorithm.
Yes, very nice. Which of the following is not an advantage of a serial search?
Quick search.
Quickest searched.
It is the quickest search. It isn't. Okay. What does the binary search do?
Takes
Take
it
the
as
data, split
Third
in half.
option, sir. Third. Takes the
option, sir.
data and splits in half.
Which search algorithm would be best to use with ordered data?
Binary
Serial
search.
search.
Binary search.
What is the advantage of a binary search?
Very quick.
It is very
Very quick.
What is the advantage, disadvantage of binary search?
it can only be used.
Use to for company.
Yes, very good. Very good. Good job, people. See if you all scored 100 or 10. Yes, you did. Good launch. Nicely. Okay, so let's go on to the more difficult part, which is writing the index-based version. Remember, your index logic is going to be heavily exercised. So let's play along here, right? So we have this logic, correct? Which is finding binary search for this. Now we're going to write an index-based version. So I'm trying to see if I can be a little bit more intelligent this time. So we are going to take these test cases. We're going to add some new test cases. We're going to say test. We're going to test binary search indexed version. Put it out here. And this code also we will say B search and index. And in this, we're going to come back and say from B search index, we're going to import binary search. Binary search, yeah, you can still retain the same name, I guess. Binary search. So we're going to start with the same logic that we had for the indexed version. So we're going to test now, right? In these tests, we're going to do what? We're going to test, we're going to expect, what is it that we're expecting 5 to be? Where do we expect 5 to be?
In the middle
The middle.
of the list.
And so therefore, what should be the expected value?
It should be true.
First of all, let's see if all this thing works. We just made copies of whatever there's there in B search and B index. And so all the test cases should pass. We're just making the same things, right? And this one, we'll go back and stop printing all these things because we don't want this printing anymore. So we go back to this binary test binary search. Before that, we have to fix our test cases, right? So we are looking for 5, and what do we expect it to return? So let me rephrase this problem statement. The problem statement is we were trying to write this before. Now we are writing if present, return the index at which it was found, right? If absent, return -1. We say because -1 is never a valid index, right? So we return -1, but if it is present, we want it to return the index at which it was found. So this is the new problem statement. And for that, so what should be the expected value here? Hello? Imagine this is the first test case we're writing. What should be the expected value?
It should be 2.
Yes, very good. So you're 2. Remember what? People are still not sure about indexing. Everybody clear? Only Samuel seems to say it's true. Everybody agree with him? Disagree with him? Any disagreement? Hello?
No, sir.
No,
No,
sir.
sir. No, sir.
No, sir.
Are you sure?
Yes, sir.
Yes, sir.
Yes, sir.
That's for the other people who may not be still clear about what this whole thing is happening. Let's let me bring that same list here. 1, 3, 5, 7, 5, 7, 9. And then I have a function which does this. Oops. Is that clear to everyone? Right? Everybody clear why Samuel
Yes, sir.
said 2, right?
Yes, sir.
This is the values in the list. This is the index of the list, elements in the list. So we expect 5 to be in the list, and it should return not 5 is true or false, but it should return 2. So that is the meaning of this test case. Got it?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
So this is 2. So we expect 5 to be found in 2, 3 to be found where?
1.
1, sir.
Right?
Sir.
And one to be found where?
0.
0.
And 7 to be found where?
Sir, above the indication you put as 0. In the above 1, you put token as 0 instead of expected outcome.
Thank you. So 9 is to be where?
4.
9
4.
is to be
4, sir.
4. And 2 is expected is?
-1.
Minus
-1.
So this is the logic we need to match up with, right? So how do we do this? So this while A list, so we have to start getting markers. Remember I showed you that GIF, which is basically, right? If you look at the binary search, wait for the index 5. It starts off with having low and high, and there's a mid index, low and high. So low and high are two markers that we need, right? So how do we define those markers? Shall we use low and high, or you want to use left and right?
Left and right.
Left is 0
Left
for
and
us,
right, sir.
right? Given any A list, the leftmost index is 0, and the rightmost index is what? Length of A list, right? Given that those are the initial values to go by, we then calculate, how do we calculate mid then? Instead of mid, using, no, so how long do we run this while loop? We run the while loop only while left is less than.
0.
So this equivalent of doing that, it would be left is less than right? The mid value. So if you want to calculate the mid value, how do you calculate the mid value? Remember this mid we calculate, right? This is code you guys wrote yourself, right? So instead of this, another way to calculate mid would be how? Somebody?
So left plus right.
Left plus right.
Divided by 2, double side.
Very nice. Floor divided by 2. Very good.
Floor divided by 2.
Okay. So we got the mid value, and then mid value remains the same, right? We calculate the mid differently than this. So we can effectively remove that. And what are we printing? Are we again printing some values? Yeah, let's print something. Let's print, we have a lot more variables that we are managing now. We're saying low, and we are also saying high, left, right? Left. So we want to know what is left, what is the value in left. We also want to know what is in right. So we are printing right. That's about it, right? That's all we know how to print, and that's what we not want. That print statement just got 2 more values to print. That's the only change we did. And again, we are checking the same thing. If token is less than, is it same? Yes. If token is less than mid value, now we're not going to use slicing. So how do you find the equivalent of this? You have to change left or right. What is the answer?
So left is equal to mid.
Left is the left side, right? You want to throw away the higher part, right?
Yes,
Yes, sir.
sir.
So you change left,
right.
or you change right?
So right, I think
Huh?
so. So right, I think so.
Right, very good. So how do you assign right? Right become what value?
Mid value.
Mid, very good. So you just take the same index that you used here. So that gives you a clue, right? The only intelligence thinking that you have to do is whether you update right or left. So that is this. And this one. So this slicing we don't need. So similarly, this, what is the equivalent of this?
Here left becomes mid, sir.
Left becomes
The mid.
becomes what? Mid?
+1.
No,
Plus 1, very nice. Yeah, so just the equivalent. So that's why the slicing gives you a very clear idea of how to write up this logic. I'm not doing anything different. We're just finding the equivalence of this logic to this one. Okay, any other changes? Now we are saying we're returning true. Should we be returning true?
No, sir.
So this while A list equal, we don't need this. This is why we have this. So what should we return? Return what? Are we returning Boolean values? Are we returning something
Boolean.
else? So what is the index we have to return?
It's mid value, then
It's a tough part of the quiz. Somebody who's going to get 100 points for this. 100 rupees. Let me put it that way. Who's the first one to respond? Quickly. Money for grabs. Professor?
Sir.
Sir, could
make
you
note of-
show the list?
Please find out who's going to get 100 rupees for this.
It's
Okay, do.
difficult. Already, I think so. Already, the Sanjeevi Kumar team also get a prizes, but today he is not open a mouth. I don't know why he is.
Sanjeev is sleepy.
Yes.
So what is the
Return
answer?
to-
Return
return
what?
to-
Sir, can you show me the list?
2, sir, I guess.
You don't need to look at the list.
The return token.
Return token.
Return index, sir.
Yeah, Sweta, tell me.
It's okay to be wrong.
Index, sir.
Index. It's wrong. Next.
Sir, 2
Return to what?
is the mid value is O.
But how can it be 2? It'll fail for the other test cases, right? You're
Ah,
always
the test
finding
case it
it.
will fail.
Next one. Next are another guess. Come on. Time. We're running short of time. Come on. 12:50. Yeah. It ends
Yeah,
at
no.
12:50, Professor.
Return token.
Yeah, sir.
Sir, return 0.
Return 0. Wrong. Next.
Sir, return exponent.
Return expected.
Index plus 1.
Index plus 1 now. What is index? Index is not even a variable here, ma.
Now people
No,
are
mid
confused
value,
with the
yes.
index question, sir.
But they're so desperate to get that 100 rupees, they're throwing anything in that. Good.
Yeah, return none.
Return?
None.
Return none. No.
Sir, mid value.
You want to return mid value.
So mid value is equal to alignment.
But you suppose mid value is a value, right? You should be returning index. What is the index here?
Index should be 2.
What is the index of mid value?
Mid. Mid, sir.
Mid value dot
Who told
index.
mid? Who told mid first?
That girl name actually. Suji?
Sir, yes, sir.
Suji. All right. Suji is the winner today. Very nice. Good job, Suji. I'm glad a girl won today.
Thank you, sir.
Oh, what? There's one more option to do. Still, we are failing. Okay. Where do you think I'm failing? What is now the test case comes and tells it's failing on what? When you're trying to find 2, it's finding that you're failing. So what is the fix for this?
Token is mid value.
What is the fix? Somebody, this is the second 100 rupees. It's a simple fix. Hello. One more minute. I like to keep up with time. Meanwhile, let me finish up cleaning up this.
Any other?
Anybody? Nurva, rumba easy. The failing test case is saying you're returning when the only test case that's failing, that's the only one that's failing, I think, right? Let's remove all that print. Still, what's printing? I'm surprised.
So instead of return false, in the end, return -1.
Beautiful. Very nice. Who said this? Samuel, no?
Yes, sir.
Great. Good. Samuel gets another 100 rupees. So there you go. That's all the code that is there. And that's your index version. Got it? Any questions?
No, sir.
So we use Cyber Dojo. This is the way of how you can incrementally. I mean, this is very different, not very different from what you do in Triple IT. Triple IT, sometimes professors give you the test cases that you want you to pass. Here, you're writing your own test case to come up with the logic. All right, feedback from everyone. You can do the QR scan on that. Send me how you felt this session was. Obviously, the session was very different. Professor only wanted me to run this for you. See if you got a sense of understanding binary search the way, in a very different manner than what typically we would otherwise teach in other colleges or even here at KITE. By the way, this example, this code that you see, I don't think you'll find in any textbook. Am I right, Professor?
Yes, sir. All the textbook will focus only for the index-based version, sir.
And even in the index-based version that we presented here, right? It's quite different. I mean,
Yeah, sir. Not much simple. They are complicated very much.
And even if it's complicated, you've understood it in the right way, correct? Because
Yes,
you
sir.
understand the binary search really well. You have every way to understand this logic in the manner that you can bring it up yourself. Am I right? Yes, Samuel, what do you think?
Yes, sir. It was very interesting as well as fun.
All right, that's the word I wanted to see. Thanks, Samuel. So, all right, everyone, give me your feedback, personal feedback as well. You didn't understand it. It was too complicated. That also is good. We just want, Professor and I are deciding whether we should do more of these kind of sessions or maybe go back to your typical teaching as well. Professor, that's all. I'm done.
Your feedback link, sir.
The QR code is there, right?
Yes, sir.
I'll leave that there. Yeah.
Yeah, thank you, sir.
You have finished the attendance?
Yes, sir.
Okay, sure. All right. Bye-bye.
Thank you, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.